number 32. Here's the table showing all 52 cards in the standard deck. And now let's read the directions carefully. It says a card is drawn at random from a standard deck. The card is not, I'm going to circle that, not put back into the deck. And the second card is drawn at random from the remaining cards in the deck. Neither of the cards drawn so far are put back in the deck. And a third card is drawn at random from the remaining cards that are in the deck. What is the probability that the first card is red, the second card is a club, and the third card drawn is a club? Do not round your intermediate computations. Round your final answer to 4 decimal places. Alright. What is the probability that the first card drawn is a red, second card drawn is a club, and the third card drawn is also a club? When you draw a card, you do not replace it. You do not put it back. Now remember, when you're doing 2 or more events, one after another, that goes with the multiplication rule of probability. But when the first event will affect the sample space, which therefore affects the probability of the second event and the events that follow, these are dependent events. So, we're using the multiplication rule number 2 for dependent events, such that the probability of A, which is event 1, and B, which is event 2 happening, equals to the probability of A times the probability of B given A already occurred. I can't spell already, can I? Okay. Now I'm going to keep it a little bit simple in this case. So you want to find the probability that a red is first, a club is drawn second, and a club is drawn third. We're going to be multiplying. There are 52 cards in my deck. Out of 52 cards in my deck, 26 of them are red. So the probability of me drawing a red card first is 26 out of 52. We're now going to look at the second card is drawn. So remember, when you draw a card, you do not put it back in the deck. Suppose if I draw the King of Hearts. Once I draw that, I do not put that card back in my deck, which means now I have 51 cards left in my deck. Out of the 51 cards left in my deck, how many are clubs? Clubs is the last suit that is right here. And if you count, there are 13 clubs. So the probability of getting a club second, given that the first card drawn was a red card, is going to be 13 out of 51 times, and I zoom out a little bit now, we're drawing a third card. So suppose I select the Ace of Clubs. I get that card, I do not put it back in my deck, which means I now have 50 cards left in my deck. I want to find the probability of me drawing a club again. Because I removed the Ace of Clubs, I only have 12 clubs left in my deck. That's going to be 12 out of 50. We can multiply the numerators and denominators, then we can divide and round the 4 numbers after the decimal. So let's clear that. That's 26 times 13 times 12. When you multiply fractions, you multiply straight across. Numerators with numerators, denominators with denominators. So 26 times 13, which is 338, times 12. So we have 4,056 divided by 52 times 51 times 50. That's going to be 132,600. Let's divide and round the 4 numbers after the decimal. That's going to be 0.0306, because that 8 right here makes that 5 round up to a 6. Alright guys, that is it for this question for number 32. Hope that made sense to you guys. Hope you enjoyed the video. Hope you understood why I did not replace the card, therefore changing the sample space, which affects the probability. I'll see you soon.